Let us discuss about word embeddings in NLP. So, first of all, what is NLP? So, NLP stands for Natural Language Processing. So, actually, NLP is a branch of artificial intelligence which is used by a computer or a machine to understand or process a human languages. So, by using NLP, we can process Hindi, English, or convert those languages that can be understood by machines or computers. So, what are the tasks that can be done by NLP? So there are multiple tasks like sentimental analysis, machine transition, text summarization, and chatbots. So these are the main tasks. Or let us take an examples that can be done by using NLP. So coming to why why do we need word representation? Nothing but, so let me tell you an example. So you, as you all know, the computer do not understand, or the computer do not understand the textual language, right? So the computer only understand is binary language, that is nothing but numbers. So that's why we will convert the words, the textual data, into numerical data, so that it can be easy for the machine or the computer to understand it. So the one of the basic representation of the number or the word is one hot encoding. So by using this one hot encoding, we can convert the textual data into numerical data. So here this is a word cat, right? So this word can be converted into 0 1 0 and so on. So whenever a computer triggers this format or this sequence of zeros and ones, then it can understand that okay, is this word means cat. So the problem, so these are that is the need of word representation for computers. And what are word embeddings? So so we have already discussed why do we need word representations, right? So now let us discuss what are word embeddings. So word embeddings are nothing but dense vector representations. So let me tell you here. So here there is an apple, right? So for that apple we are having a vector 0.52 comma 0.52 comma minus 0.35 comma, so like that 0.11. So in a graphical representation, when we go to this vector, there will be some point. So that point will be represented to apple. So coming to the word embeddings is, so similar words will have similar vectors. Let me tell you in a simple way. So there is a king and there is a queen. So king and queen are related, right? So that's why king and queen will have similar vectors. It will not have a same vector, but it will have similar vectors. The vector points are close to each other. So that is, and that's why we need word embedding, because by if we want to okay, if I want, if there is a paragraph with 1,000 lines, we cannot we cannot get every word into numerical representation and all things. But if you give apple a vector, then at any time that word repeats again, then it will use the same vector. So that's how the word embeddings will work. So semantic representation in word embedding. So what is semantic representation? So here you are having king, right? And there are, let us assume, four vectors: king, man, woman, queen. So what is the king? So basically king is the supreme of that kingdom, and he will have all the powers. Suppose I have removed a gender from the king. Let me, so I am removing the man man gender from that king and adding woman gender, then automatically what will happen? It will be equal to queen, right? So the queen also will have same powers and same authority like king, but what is the change? The gender will be changed. So that's how you can be represented. So we can capture the relationship like gender, tense, geography, and all the things. And what are the types of word representation? As I already said, one hot encoding and bag of words, and lastly we are having word embedding. So word embedding is also one type of word representation. Am I clear now? Word embedding models. So how do we build the word embedding of a particular word or particular chat and all the things? So there are some tools that I have already generated to create the vectors for particular words. So here you are having some three main word embedding models, that is word to vect. So this word to vector is developed by Google. So first thing, CBOW is nothing but continuous bag of words. So you are having context and it will generate the target word. Suppose am I saying the dash sat on the table. So it can generate the cat sat on the table. So it can predict the target word. Now it, we are having skipgram. The skipgram is if you give a target word, then it will guess or generate context words. So it was nothing but if you give it cat, for example, recent example, it will generate the sat on the table. So it will generate those context words when you give a target word. And there is glow is developed by Stanford, and there is also FastText. It was developed by Facebook. So how now let us understand about a simple one model, that is word to vec model developed by Google. So here SIBO, right? So I have already told the example. I am giving input context word, then output will be target word. So example the dash sat. So it will predict the word between in this dash. So it came up with the cat. The script gram is if you give the target word, it will give an output the context word. So if I give the cat, it will give the sat and mat. So these are the similar vector representations. So these are the similar vector representations. So the sat and have same vector representation as cat. So that's why it predicted that context word. When we are giving the context word like cat, the sat and mat are having the same representation, though not same, the similar representation. That's why it predicted sat and mat for the target word cat. So the properties of word embeddings. So so there will be semantic closeness. So king and queen have say similarities rather than compared to king and dog. So the king and queen are closely related, right? So they are having similar vectors comparing to king and dog. So the king and dog are not muchly related. So that's why rather than king and dog, the king and queen are having similar vectors. So vector arithmetic. So you can perform a vector arithmetic. So coming to walking minus walk. So if we remove walk from walking, then what will be remaining? Ing. Similarly, if you remove run from running, then what I'm having? Ing. So I can do the vector arithmetic with words in word embeddings. So limitations of traditional embeddings. So what are the limitations of the traditional embeddings that let us discuss? First is out of vocabulary. So when you are training or developing word to vec or any traditional embeddings, if there is a word that was not ever trained. So if I trained about a story and there is a word like pizza, so the pizza was never been there in the story, then it will never be vectorized. Then context insensitive, so same vector in all context. So and there will be static, so bank. So there are two types of banks. So the bank is also the thing where we store the money in financial way. And coming to geography, what is the bank represent? It will be river bank. It will be river bank is nothing but the sides of the rivers are known as river banks, right? So when we use a river bank and financial bank in the same text or anything, then it will be representing the same. Okay, the bank will be the bank sorry the bank will be vectorized in the same way. So there will be, so for that, to come over the limitations of the traditional embeddings, we are having contextual embeddings. So contextual embeddings are nothing but ELMO, embeddings from language model, BERT, bidirectional encoder representation from transformers. So these are the methods we use for contextual embeddings. So to come over these limitations of traditional embeddings. So let us keep in mind these words, then you will be encountering it in further classes. So by how do we develop an embedding? So we are having pre-trained embeddings like GenSim, Spacey, and all the things. So what are the sources we are having? Google News, Vertivect, Glow, FastText. I have already said you these before. And what the real world applications like, when will we are using these word embeddings? So you are using in search options, chatbots, spelling checks, translations, and etc. So the summary of, so let us go to the summary. So there are embeddings, real valued word vectors. So what are the models? Word to vect, glow, FastText, these are the providing the word to vect. And benefits, compact meaningful vectors, we are generating compact and meaningful vectors. And limitations, these are the limitations, out of vocabulary and static. Next, so for the limitations we have came up with ELMO and BART. What are the tools we are using? Gensum, Spacey, and Hugging Face. So here let us run a code. This is a basic code to run and visualize the how the word to vect will work to convert the normal textual or normal sequences or sentences into NL and into vectors or numbers. So for that, first we have to install Gensum tool or library. So I have installed it. Then I have to import word to vect from Gensum. Then I am having here two sentences. I love NLP and word embeddings are fun. So I am having two sentences here. Now I am training the model using these two sentences. So that model was done. Now let us see what is the vector for NLP by using these two lines of code. So this is the vector. So -0 to this, here to here. So this is the vector for the word NLP. And let us also see what are the similar words for NLP. So coming to here, what are the similar words in NLP? Embeddings, love, I, are, fun words. So these are the similar words that have been vectorized along with NLP. So this is the basic code how we can convert the sentences into NLP into vectors. So I will provide the link of this Google Colab and you can check by your own. Thank you guys.